Since we have a quiz tomorrow and we're punched for time, everybody in the room is going to get points for the checkpoint. Would Ellie like for me to look over it to make sure Ellie's on the right track? Probably. That would be smart of Ellie. But if Ellie doesn't, I'm posting the key to it on Google Classroom later tonight. She's going to look it over. If she's confused on why number 2 is on 2, she's going to come ask me during 0 period tomorrow. She wants to have that down because she likes her right. Okay. So that is my nice news, is that we're in such a hurry. Everybody's getting their points for the checkpoint. I'm posting the key to the checkpoint. But that's kind of scary because, let's face it, Ellie didn't mind if I call her out because she's not lazy. Ellie might get lazy on me, not do anything. And then, I've gotten lazy on you. I didn't check to see if Nick actually did those 3 or 4 from the packet I assigned. So this quiz, I'm just trusting that Ellie did the things Ellie was supposed to do. Because if she hasn't practiced any on her own, oh my goodness, that beautiful average. That beautiful average. Okay, let's go ahead and get this over with. Poor Jackson's group, they're so cute today. I'm still confident they can do this. In fact, would y'all like to volunteer for number 9? Or do you want me to get someone else to? No? You don't want it? Okay. While Jackson's thinking and Marie are thinking over their lives, I'm going to remind you that we're doing a whole lot of problems today. Why are we doing a whole lot of problems today? Because I'm not doing any on the quiz tomorrow. We're going to save 18 and 19 for Friday, and we're not doing any tomorrow. Okay, I've got a volunteer. Oh, you wanted to volunteer? Okay, Emery, go ahead.
I think number 9 is a problem.
It is. That extra line at the top, I don't know why it copied like that. It should just be, this is our graph. And it doesn't follow that vertical line test, so it is a function, and your group can have a point. Yes, ma'am, table 2.
Number 10 is not a function.
Not a function. I can find lots of spots where it fails that vertical line test. For instance, it fails here. Okay, number 11, Karen.
Number 11 is not a function.
Not a function. What is that? A circle. But yeah, it fails here, and it fails lots of other places too. And then you've been 19. You want to tell me number 12? It is a function that doesn't fail that vertical line test. I'm not saying it's a nice function. That sharp turn is annoying. For an extra point, and you can get a point for that. And I don't know if you got your point for yours, ma'am. Did you? You should. Okay, for an extra point, Karen, did you give your point for yours too? Okay. For an extra point, you don't have to know this now. It's going to be okay if you don't. I'm just curious if someone in the room does. What type of function is number 12? Yes, dear?
Onto.
It is onto, and you can have a point for that. No, I meant like linear, quadratic. Does anyone know that kind? Like what type of function is in that way? It's obviously nonlinear. This is correct. This is good, Jason. You can have a point for that. Remember that vocab term. Okay, it's an absolute value function. I'll give myself a point for that. Okay, number 13. I haven't heard from y'all. Do y'all not want to do one of these? Yes, dear. Oh, she stole the words right out of your mouth. And it is a function. And you can have a point for that. For an extra point, it looks like an arm. It's a specific kind of function. Does anyone know the name of this? What? Like, this was called absolute value. What kind of function? It has a name, a specific name. It's a specific type of function. Specific always gets me. Specific type of function. Yes, dear? No. Number 9 was quadratic, though. And that is a really good guess, Jax. That is a really good guess. That's, if it had that other part to it, you would say yes. But it looks like a quadratic but lying on its side, right? It's going to be a square root function. So it's like y equals square root of x.
So it would be like, are you talking about when it's like x squared?
Yeah, but do you have to know that? No, at the moment. Jason's right. All we've covered is linear, non-linear. Why I'm expecting more from you, I just was curious. Linear, non-linear, you got that down, you're fine. Don't breathe air. Okay, let's go to 14. 14, you've got to rearrange it into standard form. Yes, dear?
Is it 4x minus 3y equals -7?
No. Yes, ma'am.
I got 4x plus 3y equals 7.
Okay, and then so you added 3y to both sides. And if you want to write this in, you can. Some people are having difficulty seeing it, so if they need to write it out, they can. So 4x plus 3y equals 7. And then to guarantee you get your point, tell me what's the A, what's the B, what's the C, ma'am?
A is 4, B is 3, and C is 7.
Yes, and you can have a point. Okay, number 15. I need help rearranging. Yes, dears.
8x plus 6y equals 7.
Okay, what did you do to solve that?
I subtracted 8x into the other side, and then subtracted 7 on the other side, and then I divided it all by negative 1.
Okay, I like it. So she subtracted by 8x. She had negative 6y minus 8x plus 7 equals 0. And I'm taking it step by step, but do you have to? No. She subtracted 7 from both sides, minus 7. She got negative 8x minus 6y equals 7. She remembers x. She remembers what we were discussing yesterday, that the a can't be a negative. So she ended up changing all their signs. So she had 8x plus 6y equals, did I do something wrong? I did. That's a negative 7, isn't it? That should be a negative 7. 0 minus 7 is negative 7, so it ended up equaling positive 7. Yes, ma'am? None of that is incorrect. That is exactly the perfect. Tell me A, B, and C before I say more words. Anne Marie.
A is 8, B is 6, and C is 7.
Perfect. And you can have a point for that. Someone first period showed me I didn't think of it either. I did what Anne Marie did. Someone in first period thought of an easier way to solve this one. Someone else have an easier way? Okay. So the problem was negative 6y plus 7 equals 8x. If we add 6y to both sides, we would have 7 equals 8x plus 6y. Well, can't we just, since it's an equal to sign, can't we just reverse that and say 8x plus 6y equals 7? So A is 8, B is 6, C is 7. So you don't have to do it this way, but I didn't see it that way. I did exactly what Anne Marie did. Exactly what Anne Marie did. But if you can see that and understand, hey, if I just get the x's and y's on one side, it doesn't matter if it's the left side or the right side. That's really smart. And you can have a point for that. Okay, number 16. It's decided to work now. Last period, it decided to eventually turn on key and it stank. So just be warned. It's having a day. Ma'am.
Got 1 half x minus y equals negative 10.
So she added 1 half to both sides, or 1 half x to both sides, and she got 1 half x plus y equals 10. But you're not done, are you?
I said minus y,
Is it a minus y?
because I already on each side was negative 10.
You shouldn't do that time. You added 1 half x to both sides, so the a was already positive. So I would leave their signs alone. And then you're not going to tell me that a is 1 half, are you? I'm going to let her, she's correcting signs. You're not going to tell me that, right? We talked yesterday in our notes that a can't be, and it can't be a fraction. It's got to be a pretty number. So she's got to keep going. Can someone help her finish this? By? You can have your point, Jax. Okay, so if we multiply everybody by 2, we would have x plus 2y equals 20. And then we could identify that a, b, and c. Can you tell me the a, b, and c?
X is equal to 0. A is 0. B is 2. C is equal to A.
Oh, and Jax just broke my heart and he didn't mean to. What should he have said for x? He said 0. Is it 0?
1.
There's an understood word. Oh my goodness, oh gosh. Okay, someone last period did this different than me. I did what you did. I moved the 1 half over. I had the sign error, but anyway, you and I just adjusted in life. And then we multiplied by 2. I did this. Someone last period multiplied by 2 the very first step to get rid of all the fractions. It's not a bad idea. Especially when you look at number 17, because 17 with all its fractions, if we could just make them go away to begin with, life probably would be better. Needing help with number 17. It's a doozy. need a number that I can multiply everybody by and make all the fractions go away. $32 is so big. If they're not a smaller number, why can't we just multiply by 8? Don't 4 and 8 go into 8? Why can't we multiply by 8? Now, if Ellie multiplies with 32, she's going to end up with the right answer. Ish. She really needs to multiply by the smallest thing that goes into 4 and 8. Her answer is going to end up being like 2x plus 4y equals 8. And then you're going to say, hey, Ellie, you realize everything's divisible by 2, so really that's x plus 2y equals 4. She's making her life way too complicated. She's not going to do that. She's going to pick the smallest thing possible. Okay, so we picked 8. I do not care. Cooper does not like to show a lot of math. Man after my own heart in some ways. If he doesn't want to put the step where he actually multiplies each of these by 8, I totally understand he's doing math in his head. That's allowed in Algebra 2 with Trey. So 5 times 8 is 40. So he has 40 over 8x. 8 times 3 is 24. So he has 24 over 4y. And then negative 9 times 8 is negative 72. If he doesn't want to write that step, and he wants to just go straight to the next step of 40 over 8 is really, and then 24 over 4 is really, and then, no, I can't do anything about that. If he wants to go straight to that step, I totally understand. Okay, would some group like to help me finish this? Yes, Nick? Okay, so 5x minus 6y equals negative 72. So what is A, B, and C? A is what?
5.
B is?
Negative 6.
And C is? Okay, perfect. Okay, are there any questions about these math workshops? Okay, then we're going to do a little bit of notes, but then seriously, I'm going to give you time to look over that checkpoint, and then I'm going to give you points for anyway. But you're going to make sure you know what you're doing, because you have a quiz tomorrow, and quizzes go in the 30% category. And before I go any further, I need to stop. And I need to remind you that there is a test on Friday. What is the test on Friday? The perfect squares. Okay, so let's stop what we're doing and go over 17 through 25. You can get out your list if you need it. But people, it's Wednesday. The test is on Friday. It's Wednesday, and you don't know 17 through 25, and the test is Friday. Time is not on your side. You've got to get it together. Did anyone lose their list? And now they want to tell me because they don't have it. Or they never got it. So I got 2. Okay, cool. Okay, I'm making them a copy. If you need to have your list out, you need one to memory. Did I give you one? Did I give you a perfect squares list? Okay, perfect. If you need to look at it, you can. But again, it's Wednesday. This is happening Friday. Get there. Okay, there are, so let's say Angel has 1 through 16 down. She's got it. So that means at the moment she's getting 16 out of 25 right. That sounds pretty good, doesn't it? I hate to break your heart, but 16 divided by 25, only 64.
Holy crap.
Only a 64. Okay, so while I pass out the rest of these lists, if you look at you, Delaney, who let us know who I am. Anyone else need one? I gave them one. Name. Yeah, today. Okay. There are 2 between 17 and 25 that Nick is not going to miss. What are the 2?
20.
If you miss 20 squared is 400, then we have a problem. So surely you're going to get that one. And then there's one more that's an easy one to remember. What is it? 25. It's just 6 and then 2 5. 25 has the number 25 in it. If only Justice can remember it's 6, 2 5, we'll be good to go. So let's say Justice gets those 2 in addition to the normal 16. So that means he's out to at 18 out of 25. So 18 divided by 25, 72. It's a 25-point grade in a 60% category, and you made a 72. Not saying it's bad, but my goodness, could be better. If you don't know them, it's an easy grade, Might as well get to know 'em. Okay, let's start at 17. What's 17 squared? 17 squared. 18 squared. 19 squared. 20 squared. 21 squared. 22 squared. 23 squared. 24 squared. 25 squared. Okay, 24 squared. 17 squared. Okay, so some of these are like, I've got 24 squared is 576. I've got that. Now, I don't know why that one's 6, but it does. Some of these are 6. I have a link I need to send to you where you can practice online. That's kind of cool. That way it's like a game to make it more fun for you to get these down. Otherwise, I just have stuff in these. How long did I give you yesterday on this? I gave you a minute exactly, right?
Yeah.
Was that long enough to do all through 25? I really think it is. But I'm gonna be nice, and out of the kindness of my heart, I'm gonna give you the full 2 minutes. However, that includes writing your name. So it better be a fast name writing. Nick has to write his name and do 1 through 25 in a minute. Yeah, you better pray I can read it, or else I'm typing in a 0. Okay. That means that Nick has a little extra time, right? He's got a little extra time. So worst comes to worst, he doesn't have his calculator, because that would be cheating. But worst comes to worst, on his paper, I see where he forgot 17 squared, and he's done 17 times 17 really fast, and he figured that one out. So Nick could probably figure 1 or 2 out, just by multiplying. But again, Nick only has 2 minutes, and he's only so good. I doubt he can sit there and work out 17 squared all the way through 25 squared in a 2-minute period. He's fast at multiplying, but he's not that good. Agreed? Okay. So you got 2 minutes tomorrow. Okay. It is a challenge. It's a Friday. Not tomorrow, Friday. Thank you, Cooper. And you have a point. So that was that. Okay, yesterday we were doing math. And we talked about how Miss Compton can't copy notes. So the page that was on front yesterday is actually where we're starting today. We're not going to do that many. I might talk for 5 minutes. Maybe. We've got to do a little though because we're a bit behind. Okay, so it makes sense. 2-1, we did function, not a function. 2-2, we talked about linear functions and nonlinear functions. So it makes sense right after you talk about a linear function, you know we're going to start calculating the slope. So no wonder 2-3 says rate of change and slope. So the first blank is actually rate of change. Nick, do you have a nickname? Huh? And your full name's Nicholas? Okay. The way Nick is both Nick and Nicholas, rate of change and slope are the same thing. They mean the same thing. So rate of change is a ratio that compares how much one quantity changes relative to the change in another quantity. And then notice further on it even says the rate of change is the change in y over the change in x. Does that not remind you of the slope formula with the y's in the numerator, the x's in the denominator? Same sort of thing. If you're going on to higher math classes like pre-cal and cal, eventually they start talking about rate of change and they call it delta y over delta x. They get fancy and start throwing in some Greek letters. So don't be scared if you start seeing delta y over delta x. It's the same thing as rate of change, which is the same thing as slope. Okay, so our first example stinks because the paragraph is written underneath. So it says something about this table shows the temperature of a solution. It's been removed from a heat source. Find the rate of change in temperature for the solution. Okay. So rate of change, we need the change of y divided by the change in x. These are, the time is our x values. The temperature is our y values. Because the temperature is depending on that time, that's how I'm deciding this. Looking at this table, Is there a set pattern increase anywhere in the numbers? Do you see like a consistent pattern anywhere? Like I know this one increases by 2 and this one increases by 3. So that's not the same. Is there anywhere you notice the same thing happening? That one's by 2. This is by 3. Okay, I'll use more words. From 5 to 8, how much did we add?
3.
And from 8 to 12, how much did we add? 4. So was there any consistent change? No, it wasn't consistent, but then we add by 3 both times over here. I see a plus 3 and a plus 3. And then I need to get the exact same numbers that match over here, because if they don't match, we're not having a linear change. Now, today, since we're talking about rate of change and slope, everything's going to end up being linear. But in real life, just because I hand Ryan a table, should he assume the information in it is linear? No. He needs to check, does it have this set increasing pattern? So that's what we're looking for in blue. If it's increasing by 3, it should be increasing by the same amount in temperature. Or decreasing, we'll see. Okay, so you went to your calculator. You typed in 143.6 divided by, or minus 139.4. And you got, someone has a calculator other than me, 4.2. And since we're going down, it's minus 4.2. Okay, and then you did 139.4 minus 133.1. What did you get? Okay, and then you kept on going. 133.1 minus 126.8. That's an 8. What did you get? 6.3 again. And so, ding, 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 I know it's linear because when we were increasing by 3, we were always decreasing by 6.3. But that's just a side note for those of us who are curious. Okay, and then I need to do 126.8 minus 118.4. Okay, and we went down, so it's minus 8.4. Perfect, thank you, dear. Okay. So, let's face it. Amory goes to home. She sleeps at night. She lays her head down on her pillow. She forgets how to do rate of change. Worst comes to worst, she can always go to her handy-dandy slope formula, pick 2 points, and let's say she'll do 139.4 is y2 minus 143.6 is y1 divided by, and then x2 minus x1 would be 2 minus 0. So she ends up getting negative 4.2 over 2, and that reduces to something. I need to know what it reduces to. What is 4 points? Negative 2.1. Amory goes home. She sleeps at night. Worst comes to worst, she comes back to this problem and she uses that slope formula. The slope formula is always going to help you figure out the rate of change. Angel can do that every problem if she wants. But maybe Angel is like me, and she's a little lazy. And she really wishes she didn't have to do the slope formula every single problem. I get a little old. So maybe instead, she notices something going on. Rate of change is always the change in y's over the change in x. So for instance, didn't you and I already calculate the change in y was negative 4.2? Didn't you already calculate that the change in x was 2? So I don't even need this formula. I already had all the information. I do the y value, the change in the y's, divided by the change in the x's, and heck, I would have gotten negative 2.1 anyway. Let's say Cooper doesn't believe me. Maybe he picks a different spot on our chart. Negative 6.3, that change in y's, divided by 3, the similar change in x's, isn't that also negative 2.1? And then if he wants to triple check me, I'm pretty freaking positive negative 8.4 divided by 4 is also going to be negative 2.1. So he doesn't even have to use the slope formula. When he's finding rate of change from a chart, he can literally just find a change in the y's, a change in the x's, put this in the numerator, that in the denominator. He is done. Are there any questions about that? Then we're going to practice it 4 more times, and surely by goodness you'll have it, and we'll stop talking about it. Okay, so can you tell me a change in the x's? What are we increasing by? And it actually is increasing by 2 each time. We don't have to note that, but I'm a nerd, so I'm going to. Okay, what is it changing by in the x's each time? So we're adding 12 each time. And I already know the answer. What is the answer? Change in y divided by change in x. It's going to be 6, because change in y is 12. Change in x is 2. So my answer is 6. Again, if Justice gets real bored and he wants to do y2 minus y1 over x2 minus x1, he's still going to end up getting 6. But this makes life so much easier. Are there any questions about number 2? Why is number 3 harder? It's harder because it's not the constant increase, yes, but it's also harder because of the time, which is what Angel said, and then Karen caught on too. The time is the problem. But that's fine, we can still find it. What are they increasing by over here? They went +7, and then on this one they went +2, and if you want to, you can keep on going. I'm not going to, I'm getting lazy. What's the difference between 26 and 61? Didn't they increase by 35? Didn't they get 35 more people? Okay, and then 61 to 71? What is that changing by? Okay, so what is my answer? Changing y over changing x. What is my answer?
Isn't it just off?
It is. So you could do 35 divided by 7 and get 5, because that was the difference in the rate of change between the top 2 values, between here and here. Or you could have gone to the middle of the table and done 10 divided by 2. You would have also gotten 5. Heck, maybe Cooper wants to be different, and he goes down here to the bottom. He noticed it increased by 10 minutes and increased by 50 people. 50 divided by 10, hey, it's also 5. So you can pick anywhere and look at that change in y divided by the change in x, and you'll get the correct answer. But again, this is all happening because I'm a math teacher, and all the stuff we've given you is linear stuff. Any old ordinary table you see on the ACT, you should not assume this is going to work. These are linear tables. They're representing linear data. Okay, and then I think, because there's our notes we did yesterday. Yay, they're out of order. Our last 2 examples for the day are 4 and 5. They're on the top of the next page. I'm going to pick in the middle of the table this time just to prove we can do it anywhere. So between 15 and 23, what am I going up by? Okay, and then you can figure out the other side. I need to know the final answer. It is 362. So you did 28326 minus 25430, and you found out the change in y was 2896. And then you said 2896 divided by 8, and you got 362. But again, Justice wants to be rebellious. He likes doing the top 2. He's still going to end up getting 362. Or Justice wants to be super rebellious and use that slope formula because he just loves math so much. He's still going to get 362. Okay, and then our last example, pick anywhere on the table you want. Tell me what you get for the rate of change. Angel, add a point if you didn't already.
Isn't it a decimal?
Oh, yes.
2.363.
I don't know that yet. I know you want me to, but I don't. Say it again. That's what I got. Is that what everyone else got? Okay, so I did it here because I'm lazy and it was at the top. I saw it changed by 3. Over here, 37.3 to 30.2. That's a decrease of 7.1. So I said my rate of change was my change in my y's divided by my change in my x's. And I got negative 2.36 repeating. So I'm going to say 2.36 bar. Or maybe you want to say negative 2.37. Not really caring today. As long as you understand what's going on. Okay, Angel, the only thing she said wrong in her answer is I don't think she said negative. Since we are decreasing on those y values, they're going down. It is a negative 7.1. Okay, I'm done saying words and I hear you packing anyway, so perfect. Yay. Posting the